Hi, everyone. This is Rob Gray from ASU and the Perception Action Podcast. And this is the third article in my series looking at some of my favorite research articles from 2020, kind of giving you a breakdown and kind of my view on things. And then this article, we're going to look at the effect of fatigue on movement coordination. So when I talk about the constraints-led approach and I talk about the importance of movement variability and being able to adapt, one of the examples I almost always give, I think, is when talking about the individual or organismic constraints on a performer. One of the ones I always talk about is fatigue, right? So one of the reasons you need to be able to move in different ways and can't just have one technique is because you get fatigued, right? The same muscle output is not going to lead to the same force, the same velocity. So you need to be able to adapt. You need to be able to adapt to fatigue. So I'm always saying that, I think, every time I present on constraints, but rarely have we looked into specifically how your coordination changes as a function of fatigue. What's going on? How do you adapt? And the study I want to look at today did just that. Right. This is work by Wolfgang Schollhorn and colleagues looking at the effects of fatigue in what they're going to look at is karate kicking. So this is a paper published in Frontiers. You can find a version, open access version online. So this work I'm going to talk about today builds on previous work that Wolfgang Schollhorn has done using a technique he coined as what he coins coordination profiling, right? And we talked about this a fair bit in the interview I had with him. I was lucky enough to have him on the podcast back in episode 304. If you want to listen through, he talks about this. Coordination profiling is basically a technique where you take a bunch of data from individual performers. So instead of having a little bit of data from a lot of performers and taking means and averages like what we typically do in a lot of research, what he does is take a lot of data, sometimes over years, from a small number of performers, right? And what you do in coordination profiling is you use different analysis techniques. Usually it's most commonly some form of machine learning to try to classify and identify the different performers based purely on their movement data, right? So what we're doing is we're going to give the algorithm, the machine learning algorithm, data, kinematics data we collect on a performer and try to train it to see if it can tell, okay, there's Jane, there's Joe, there's Julie, there's Jimmy, right? Based solely on their movement. And it turns out amazingly you can do this. Wolfgang's done some work, amazing work, looking at this over, like, for example, long jumpers over several years. You can identify who's who, again, based solely on their movement. And sometimes I joke that this is kind of like the psychological profiling you see of serial killers in movies, right? We're trying to pick out the key features so we can identify a particular person. But here we're talking about using movement patterns to identify them. So that's what, as I said, that's what they're in this study, they built on this technique, right? So what they wanted to do was to look at, first of all, will coordination profiling still work if you fatigue people, right? So if you take a bunch of people and you have them perform a movement over and over, right, and they get tired, you would expect that movement to change, right? So we might expect it to get more and more difficult to tell who's who, right, if the movements are changing due to fatigue, right? And one of the things they emphasize in this paper, and I'm going to talk a bit about, is time scales of changes, right, that happen, right? So what we're talking about here, being able to identify individuals, those are longer timescales changes that happen as they acquired the skill during learning, right? Those changes in their coordination patterns is what is going to allow us to tell the difference between them, right? So they're happening over a longer time scale. So can we still do that? Can we still identify individuals even though they're getting fatigued? The second thing you wanted to do is, can we actually identify the changes that occur with fatigue, right? Can you train a system to say, oh, this movement happened in the first block, this one happened in the 30th block after they've been practicing for an hour and fatigued, right? So what we're trying to look for is more short-term temporary changes, right? The learning is more permanent, right? fatigue is obviously temporary. It's going to go away after we we rest, right? So I think these are really interesting questions to ask. So what they did in the study is they took 16 experienced karate athletes, so karate performers who had either brown or black belts and been training for a long time. And what they had them do was execute front kicks, right? Several front kicks. And I'll show you the actual how much they did it and when in a second. And they motion tracked with 42 different markers, and shown in the image there, over mostly on the lower body, with some on the upper body. As I'll talk about it in a bit, I think this is a really interesting choice of the skill, right? Because karate is a skill that's taught typically in a very repetitive, isolated, right? It's all about producing the same technique, right? So it should be a thing for which coordination profiling is difficult, right? Because you're deliberately trying to get all the athletes to move in the same way. So that's what they did. Here's what the amount of kicks they did. So they did 9 blocks of 10. They did within the blocks, they had different kicks they were doing. They did a total of 9 large blocks, okay, that were broken down into smaller ones with 90-second rest in between. Sometimes they did both right and left foot kicks. Sometimes they did kicks at 80% of their maximum effort. Sometimes they tried to do a full out maximum kick. Okay. So from this, there were so they're doing it for a long time. And I'm not going to show you the data, but they also collected data on heart rate and perceived effort and a bunch of other things to show you they were getting fatigued by the end, like by any traditional measure of fatigue. So in the end, they had 606 kicks for each participant, right? So as I said, there's a very different approach to understanding motor learning than doing a really little bit of data, right, for one participant. And the type of machine learning they use is what's called a support vector machine classifier. I'm not going to go into the math at all of this or the details of all of this. If you're interested, you can read the paper. I don't really want to. It's just a machine learning kind of approach. It's nothing that's being used in lots of different approaches, but I don't really want to go into too much detail about it. So what they did in the machine learning is use the very traditional method way you do this. So for those that don't know, what you do in machine learning is you give the algorithm, you enter the algorithm, you give it a chunk of the data, right? So for example, we could give it in terms of the sets. Remember, there's 9 of those large sets. What you do is you give it 8 sets, right? So you enter into your machine learning algorithm, you give it 8 sets of data for the 16 different performers. You tell it, this is the kinematic data for performer 1. This is the kinematic data for performer 2. This is the kinematic data for performer 3. The machine learning does its magic, right? And what it does is it finds patterns of kinematics, right, that are distinct for the 16 different people, right? It learns, you're training it. It's learning to identify features that allow it to distinguish between those 3. So that's the training. Then what you do is you give it another set, right? A test set. So a set that wasn't used for training, a totally different set of data on the same 16 participants. You ask, okay, which participant did this come from? 1, 12, so on, right? So you trained it, now you're testing it, right? And you can see there they tested it for the 80% kicks, the 100% kicks, and so on, right? So that's the basic logic of machine learning, okay? What do they find? Okay, the first thing I want to look at is the inter-participant. So comparing the different 16 participants, right? So this is the basic coordination profiling. What you can see here, what's shown in this table, the main thing to look at is the far left accuracy. What you could see is machine learning algorithm could classify the participants with 100% accuracy, right? So in the test data, it could tell which participant the data came from with 100% accuracy. Right? This is pretty amazing, right? It's pretty amazing. This is just movement data, just numbers of angles and joints and movements, and it can say that's participant 1, that's participant 5, so on, right? The kind of new twist on this, though, is it's doing it even though their movements are presumably changing across the data set, right? There's extra noise or variability in the data set because of the fatigue, right? They're changing, but it can still tell them, right? So it's quite big. And the point that Wolfgang makes, and I would emphasize too, right? The key point this emphasizes coordination profiling like this, being able to classify people with 100% accuracy, would be absolutely impossible if they all moved in the same way and used the same technique, right? They all use the same kicking technique. There's no way you could train an algorithm to tell them apart based on their movement, right? So they're doing something different. They're not all moving in the same way, even though they're all experts, right? So that's the really, really main point to make from coordination profiling. Okay, so that's between participants. Now let's look within the participant, right? What happened over the course of the movements as they got fatigued, right? So what they did for this was they had the classifier, again, it was trained on some set of data and it tested on another. What they had to do was they gave it kinematic data for one participant and said, which block was this? Was this the first block they did, the middle 10th block, or the last 27th block, right? So the classifier is trying to figure out which in the sequence this came from. And what they found is they could do this with 43% accuracy, right? And compared to the 100, that doesn't sound like spectacular, but think about that. The chance level of guessing 1 out of 27 is 3%, so it's way above chance. And think about it. This is within one performer that's just changing slightly and slowly over 27 blocks, right? So the amount of variation is not very big that you're giving to the model to try to figure out a pattern of what's changing, right? So this isn't different performers. This is how one individual performer changed over 27 blocks, right? And it can do it with almost 50% accuracy, can tell which block it came from. Right. So that's pretty impressive. Obviously, it means there's something going on with their movement pattern, the kinematics with fatigue, that allows the system to tell which block it is. Right. Another interesting thing that you can see in the study is when you look at when it makes misclassifications. Right. So in the model, right, you give it data that was from trial 6, right? Correct means that it told you that was block 6, right? And the way that you can express this in terms of the machine learning analysis is the distance from the true class. So a distance of 0 means it got it exactly right. It was from trial 6, it said trial 6. Distance of 1 means the data really came from trial 6, but it said it came from trial 5 or trial 7. So it was very close, it just missed by 1. And what you can see is in this figure is showing that most of the data, most of the classifications were perfect, right? Or they were one trial off, right? And this is a typical thing you see when you have a good machine learning algorithm, right? You would expect this to go down continuously, right? So it would make most of it would be accurate. It would make, if it missed, it'd be 1 off, 2 off, then it would start to go down. So it would make very many where it was 12 blocks off, right? It wouldn't make very many at all of those, right? So expect that to go down smoothly. It sort of did, but you can see there's also some interesting pattern going on there where the bars are jumping back up at multiples of 3, right? So that's going down 0, 1, 2, then back up at 3, down 4, 5, back up at 6, down 7, 8, back up at 9, right? So what we see here, what seems to be happening is there's changes in the coordination profile, the movement profile of the individual that's occurring at multiple time scales. Right, there's some continuous change that the system can identify, but there also seems to be one that's kind of periodic, happening every 3 blocks, right? So that's really interesting finding. The last result I just wanted to show you is that what they found was fatigue did not produce a systematic change, either a decrease or an increase in variability, right? You might expect that might be what happened. There was a very large amount of variability, trial to trial variability, but there was no systematic increase as you got more fatigued, as you got to the end, right? So I think those are some really interesting findings. What do they mean, right? Well, as I said, I think the fact that you can do coordination profiling of this type in karate is really quite amazing, right? As I said, karate tends to be a technique that's very form and a sport that's very form and technique focused. Right. So you'd expect people to have very, very similar movement patterns if they're going to have any. And it's lots of isolated repetition in karate. And despite that, we still see people developing, self-organizing towards their own individual movement patterns. Right. This allows Schollhorn and colleagues to do this coordination profiling. If they didn't come up with their own individual ways to kick, despite being given traditional, very repetitive technique, you wouldn't be able to do this coordination profiling with that accuracy. So I think that's a really important point. Another important point they make is that these kind of changes that are occurring right across the with fatigue. So that's kind of the inter-participant data result. If we look intra, the changes that are due to fatigue, we see there's kind of some adaptation process. It's not a falling apart, right? It's not just an increase in variability where the person can't do the movement anymore, or is very sloppy or less precise or less accurate. What's happening is a change in the pattern of movement they're using to produce the skill, right? And what they refer to as a continuous change of the intrinsic dynamics, right? So there's a change in the coordination they're using to produce that skill. It's not the fatigue changes they're observing are not because the system's falling apart. It's adapting somehow. It's changing over these different timescales. Okay. This suggests this interesting idea they raise is maybe there's not like we have this tendency to want to say sometimes there's an optimal movement pattern for each individual, right? If in ecological approach, we accept that it's going to be different for different individuals due to our intrinsic dynamics and individual constraints. Here, they're arguing maybe there's not just one, right, that we have. Maybe there's multiple ones, a kind of a dynamic optimum that changes over the course of things like fatigue and different time scales. And, maybe as we age and things too. So I think that's a really interesting idea. Another thing they talk about they talk about, maybe fatigue in training is not something we should think of as a disadvantage, right? When learning is going to be sloppy and messy and we don't want to really try to work on skills when people are tired, but actually think as another type of fluctuation or kind of a differential learning variability that we can add to the system, right? Because as they show, it seems to be these fluctuations are occurring over different timescales, and people are having different coordination patterns, right? So it's not the case that things are just falling apart. People are moving to different coordination patterns. So it's another way to essentially add variability to the training conditions by fatigue instead of thinking of it as a negative thing. I think that's a really interesting idea. Okay. So that's it for this article. As I said, I think it's a really interesting study and kind of builds on Wolfgang Schollhorn's work. If you're interested, as I said, to learn more about this coordination profiling idea, check out the interview I did with him on the podcast. So that's it for now. I'll be back with another article in shortly. Thank you for joining me, and cheers for now.